Hi guys, so today we're going to create similar components with the Polygon and other geometries within Grasshopper. So if you open up Grasshopper, we can begin. So if you type in Polygon, you're going to see that there's going to be a component that you can pull onto your canvas. And what it's going to prompt you for is a plane for reference, the radius, which is going to be the size of it, and the number of segments that you need to articulate it. This is also for a fillet here if we wanted to round the edges, but we're not going to be using that in this exercise. So in terms of the point or plane, I'm just going to set a point into Rhino space, associate it to a component, and then plug this in for my plane geometry. And this will put the polygon anywhere where that point is. So then for our radius and the number of segments, if you pull up a number slider, this is what we'll be using for that. I'm going to change no, this is fine. The radius can be a floating number, but this segments, making sure it's a full integer, and I'd say make it up to about 10. So you have to go above through 2 in order to get it to be a polygon. So you can also set your minimum to be here 3, so that your range is between 3 and 10. So for those of you also working with rectangles, you can use this component, the polygon, and set the segments to 4. Or you could also pull up a rectangle component, and it asks kind of the similar set of rules. It's going to ask you for the distance for the radius, and then the x and y directions and size, and then as well a plane for reference. But both ways are possible to work from. The reason I'm showing the polygon version instead of making up curves from points is because it might simplify some of your definitions, especially when we start to rotate and loft these geometries. So for this one, the one exercise I covered in class was extrude to point. I'll show it here again, but then I will also show how we can just loft it to another segment. So if you bring up that component, you're going to see that's going to ask for a base, which we can use as our polygon, and then the point to extrude to, which we could also use as our point of reference here. So let's use that, but move it up in the z direction with a z vector, a certain distance. So I'm going to copy this, plug this in so we have some control over the distance of our move, and then for the geometry I'll put the point into there. So now if I play with this, you can see the point will be moving in the z direction, just based off of this component. So for this now, the output geometry is this new point that we have, so we can use that to be the point that we're going to extrude to. And for the base, we can use this polygon because that's the polygon that we have defined here. So I'm going to plug that in here, and you'll see that we have a new extrusion that's going to have the abilities to be changed in angle based off that point. Also for this radius and size, this is how you would start to change the base size of it. So with this, this is the one way. For some of you, you didn't want to extrude it to a point because it wasn't part of your initial set. So what we can also do is create a copy off of scaling this initial geometry. So if you type in scale, you'll see it's going to ask for a geometry, a center point, and then the factor to scale it by. So if we use our polygon geometry, and what was this, the center point, we can use this point as it is the generator for that. And then the factor for scaling, I'll copy another slider over here. And with this, I'm going to turn off the extrusion for a moment. You'll see that you can control the size from 1 to 10 off of the domain of what's set by this size. So if we make this one bigger, it's going to be associated. So if we move this now, the same kind of direction up, we use this geometry instead of our point, you're going to see that it's going to go up, and then we have the ability to scale it. So if you turn this off, because we don't really need that instance to be focused on, and then if you loft between the two of these, this will work. you're going to get a truncated kind of form, which I think more of you are working with than a pointed form. So this is moving that second curve and then changing the scale of that second curve. So for this, then, whether you work with the extrusion or a loft, what we covered was also how to decompose or deconstruct this geometry in order to get it rotated and copied, to start getting an assembly that's more easy to work with than in Grasshopper, because you can control things globally like the radius, the size, angles, and the counts. So we're going to pull up deconstruct brep and then put our lofted surface into there. And what you're going to see is it gives you faces, edges, and vertices, which you all know pretty well by now, I think. So in order to get this information isolated, as it's going to be, if I put a panel in here, you'll see what it's thinking as. It's giving me a list of items. So in order to isolate the information so that we can work with it, instead of saying, okay, if I put one component into edges and I want to rotate about an edge, it's not going to know which edge to rotate around because there's 11 that it's providing you. So what we use for this is called list item. And with this, if you plug this in and then get an index color, make sure it's whole numbers because their index is working by whole numbers. And highlight this, you're going to see this green line for this edge is highlighted here. If we move this around, you're going to see that it's going to change for the edges of the geometry. And I want to go off of this one, so we're going to look for that. I might need to increase this. Yes. There we go. Okay, so it's item 14. So if I were to do the rotate 3D off of this, it's going to ask for what geometry to rotate. We're going to put the lofted surface into there. And then the angle for it to go off of, we've covered this one already. If we use a slider and then call out the radians component, when you enter a degree, which is more likely what you've been working with before, and then input this into your angle, we can bump this up to 360. It's going to translate it to radians for you. So then it'll, because it's asking for radians, this is why we're changing it. So let's say we worked with something at like 90 degrees just to test to see if this thing is working properly. Okay, and then it's going to ask for the center point. And this is when we use the point on curve component. So I'm going to also use this, and it'll give us the point that's on this curve. So then when you use this, it'll have the center point relative to this curve. But it's all oriented right now to the z-axis for our axis of reference, and what we want to do is provide an axis that's along these 2 points. So for this, what you can do is create a copy of your index collar. Actually create two, because you're going to need the 2 points, and then plug your vertices in as your list, because we want to call out which vertices to work with. And then if you highlight, I'm going to disable the preview for this, highlight this, and see if you can see your points. There we go. Okay, so filter around, it seems like 0.8 and 7 are what we need. Yes. So now with these 2 points, create a vector, a 2-point vector, and then plug this into your X. And now if you enable this preview again, you're going to see that you're going to have a geometry here that's going to be rotated, and we had it at 90, so it's checking out, it's at 90 degrees. If you play with this, it'll be rotating around that edge. So I'm going to pause here, and then in the next one show you how to aggregate this to a higher level of assemblies around these points.